In the previous video, I showed you the new PCB that I created in order to generalize a couple of the projects that I had worked on. And in this video, I actually wanted to show you the projects, a couple of the projects, as well as finish integrating the PCB into the existing projects. What got me interested in developing these PCBs was the need to develop a board in order to hack out this solar-powered owl here. Unfortunately, the owl had a crack in it. It got hit by a soccer ball and cracked as it hit the ground. And I decided, well, instead of just fixing it because it had gotten some water into the chip, this just used a basic YX85 something solar chip boost converter combination, very typical 1-cent chip that they use for these sorts of things. And what it would do is when it got enough solar, it would shut off the lights, charge the battery. When the light level dropped low enough, it would then just turn on the owl's eyes and drain the battery, which used a AAA battery, I believe, a couple of hundred milliamps maybe of power. It barely lasted more than 30 minutes, an hour, just because we don't get a lot of sun where I had it. And I decided to open it up and change it around, make the eyes independent. And now I'm only using the solar as basically something similar to an LDR, where you just check the amount of light that's coming in, and it's totally powered by a charged battery. The solar is actually providing no charge anymore. It just indicates how much light is coming in, and we can show it switch on. I have an Attiny in it that basically wakes up every 8 seconds and checks the light level. When it goes into sleep mode, it uses barely any current. It uses in the microcurrent range. In fact, it was so low that I couldn't even measure it on my multimeter. And I put in a bit of Attiny programming, Arduino programming on the Attiny85 to do some random eye switching. And I'm using PWM, pulse width modulation, on the eyes in order to save even more battery power. One of the additional things that I found with the Attiny is on the VCC pin, which is the first pin on the left here, you can actually monitor how much battery or the power level of the battery. So I have another LED, a red LED, that then comes on as an indicator when the battery is low as well. So let me open her up and I'll show you what I had initially done, and you can see why I decided to generalize this whole thing. And my problem is I'm always worried that when I'm pulling out the insides that I'm gonna somehow pull off some of the wires and whatnot from the board. Let me just do this somewhat carefully here. Okay, looks all right. I did tape in the wires to keep them from getting pulled out too much. And the tricky thing here is to also get the battery out as well. I'm using an 18650 battery, which I reclaimed out of an old USB power charger or a power bank. This particular 18650 is actually not fully charging, or it's only holding about 600 milliamps of power, but it still seems to be enough to give me about 1 month of a charge, which is fine for this. Okay, let me pull this out here. Well, this is just a rat's nest of wires at this point. I'll see if I can improve that as well. Okay. Oh, you can see here that the covering for the back of the 18650 is coming out, and this tape is just getting all nasty. Let me just cover that to keep it from shorting. I'll have to retape that, make it a little bit nicer. Okay, you can see if we can actually switch it on here. So what it's doing is it's going through an 8-second cycle, and if the light is low enough, it's going to then power on. What I have here is a TP4056 charging module. that I use on the 18650 in order to charge it as well as protect it from overcharging or over discharging. So overcurrent, all that sort of thing, undercurrent, overcharging, under discharging. Here, on the left side here, these first pin here on pin number 2, and it's going to be a little bit small to see. I know it's a bit distant away. So we have pin 1, pin 2, pin 3, 4, 5, 6, 7, 8. Pin number 1, which is the VCC pin. Pin number 2, I believe I'm using to check my solar power level. Pin number 3, I'm using as my indicator light, my red indicator light, which is this here. I have one inside here. What it'll do is it'll actually make the owl glow red, which is a nice effect. The 4th pin I'm not using. 5th pin I'm using as the right eye. 6th pin I'm using as the left eye. 7 I'm not using, and 8 is the ground pin. So pretty straightforward use of the Attiny85. The thing, I could have used a smaller version of the Attiny, probably a 25 or a 45. I just happen to have an 85, and the nice thing that I found about it again was that it tells me the amount of power that's left in the battery, amount of voltage left in the battery. So it's a good way to switch it off and do a kind of a secondary power protection. So this was actually very similar design that I then used for a PIR module, or passive infrared sensor, that switches on when you walk by it. And I'll open this one up too. So this is just a dancing candle that I bought off of AliExpress. In fact, most of these parts I've bought off of AliExpress. Okay. And so in this one, I'm using a 2313, I believe this chip is, which again is an Attiny. And this is the front of the chip here. This is the pin 1. And on this one, the ground is all the way down on the bottom. I'm sorry, VCC is actually up here. This is the reset pin. I'm mistaken. I told you the wrong thing here. Actually, on the pin 1, it's the reset pin. VCC is over on the right side here. So this is VCC, this is ground, this is reset. Now this one required a bit more circuitry, a bit more components, because it does not have an an analog to digital pin on it. So I had to use switching from transistors to basically trigger on a reset when the PIR module was triggered. And I'm using the Attiny to then go through a loop. And if it keeps getting triggered, instead of resetting, it's just continuing the loop onward so that it keeps the light on. And then it keeps it on for 3 minutes. If it's not triggered within that 3 minutes period, it then switches it off. But again, very similar structure of 18650 battery, TP4056, powering the Attiny, and then the Attiny using some of those pins to then power or drive an LED. So with that in mind, I designed this PCB module, which generalizes that whole structure. So on the top right side, we have the VCC in, reset, ground on the bottom right. I then have the PWM pins over here, analog to digital pins over here. TP4056 then can rest right on top of this. You have the battery connector on the top right here. You have an input for the solar, which in the case of the owl I'd be using. In the case of the PIR module, I have another input over here. And in hindsight, I've actually could have reused this here for the solar input as well. But it's fine. I can use either one of them, or I can use both of them in the future. Just gives me more options. So why don't I go ahead first and go over to the computer, and I'll go through the PCB design with you. And then I'm going to go ahead and finish soldering this up to replace the owl circuitry. So this will eventually become this nicely structured one, and hopefully we'll see that working as well at the end of the video. So we're back here looking at the PCB layout for the projects. Let me switch off the copper pour, and this way we can see the actual traces a bit better. So in the case of the owl, what's happening is you have the solar input coming in into the positive here, which is going to give us a voltage, and that's going to flow in to this pin over here, which is A3 on the Attiny85. And what that's going to do is every 8 seconds, the Attiny wakes up from its sleep cycle, checks this pin. If it has sufficient voltage to this pin, it's then going to go ahead and start cycling through the blink process for the owl's eyes. Well, actually, before that, what it's going to do is it's going to check the voltage. Let me show you the code here, actually. It might be a bit easier to understand this way. So the first thing we're doing is to set a function to read in the VCC. So this pin over here is going to get read in for the amount of voltage coming in. Okay, and it's just creating a very easy to read from from millivolts into volts. It's just changing that here. Setting up the watchdog timer. This is the thing that makes it go to sleep. If the voltage is high enough, it's just going to continue its sleep cycle, which is going to use very little current. And every 8 seconds, it's going to wake up from that and check the voltage, and also check the solar panel to see how much voltage is coming in from that. So this is the cycles, or the amount of time that the owl eyes are going to stay on for, or the number of loops, I should say, that it's going to process. I have it set to a low number of 300. This way it switches off relatively quickly. Setting the red LED, which is the indicator. This is the left eye and the right eye. Take a look here. So indicator here, left eye and right eye. This is the time interval of switching off the lights, so 500 millisecond time interval for switching off the light, and also leaving it on, I believe. This is the amount of power, or the pulse width modulation, how much time to spend on the duty cycle, so 75 out of 255, so only about a quarter of the time it's going to be set to high on that pulse width. So I'm not using a lot of current to power these left and right eyes. Okay, now we have the setup, so we just reset the watchdog. This is just a standard housekeeping item. I'm going to set all the pins to output pins, and again, and this is just to save a bit of power as well. If pins are set to output, they don't use as much power when the Attiny is on off of sleep mode. I'm going to set pin number IO pin 3 and IO pin 2 to inputs so that they can read. So this is 2 and 3. This is solar, and this is just a randomness, which I'm going to use in a minute. So this is the amount of delay, and this is the delay time between actual blinks. This is the amount of time it's going to give me. It's going to give me somewhere between 3 to 4 seconds of delay time, just to add a little bit of interesting delay to things. This is the function to control the left eye. So this is a left off. So first thing it's going to do is to switch everything off. So this is switch off left eye, keep on the right eye, and then a delay. This is off on the left eye, I'm sorry, right off, left on, so it's going to switch off the left eye, I'm sorry, switch off the right eye, switch on the left eye, delay, This is going to switch both of them on. Okay. And the right eye, on, off, both on. This is them blinking. So this is them winking, essentially. This is the left wink. This is a right wink. This is both of them blinking. And then I have combinations of them, again, randomized. So in this case, I'm randomizing 5 possible combinations. In the case of combination 1, or I'm sorry, case combination 0, it's going to blink left eye, then blink right eye. Okay. And then it's going to switch that. It's going to go blink right eye first, then blink left eye first. Case 3, just blink right eye. Case 2, just blink right eye. Case 3, just blink left eye. Case 4, do a series of blinks, which means both eyes. So when I say blink, it means close both eyes. If blink left eye or left eye just means just close the left eye, close the right eye. Again, delay between. And then we have a default. And then this is the actual loop which is going to run when the Attiny is not in sleep mode. All right, so it's going to check the voltage coming in to make sure that the battery has enough power. It's also going to check if there's enough cycles running. Let me lower this down to 300. This should be 300, so it should match the above one. This is going to tell whether or not it should be on because it's been running for a while. If it's been running more than 300 cycles, it's not going to run this. It's going to go into sleep mode again until that electrical power gets reset. Essentially, the solar power gets reset again. If the power is too low or the solar voltage is too high, it's going to go to sleep. If the voltage is too low, it's going to go ahead and switch on that red indicator light, and it's going to make sure that the blinking eyes do not blink, or that the eyes are off as well. Okay, and if that low power is not on, it's going to go ahead and go through that cycle. And then we have the function to go to sleep. Okay, so now that you've seen how the code is written, I can explain what's happening here with the Attiny and the PCB board. So we have the solar power coming in here, going to this pin over here on the Attiny, which is checking for the amount of voltage coming in off the solar panel. If the voltage is high enough and the VCC is getting enough power from the battery, which is coming off the TP4056 module here, so it's flowing in here, it's going into the VCC. Both of these things are getting checked. If it's high enough, it's then powering the PWM. So it's driving the LED here, which goes across the resistor. So I'll have to cut the track over here so that I can use a resistor in here. And I can then stick an LED in here, which is going to go between the output of the Attiny, which is going to be the positive pin, and then the negative pin, or the cathode, is going to go to the ground here, which is already connected. So I have the anode here, and the cathode will go here. And I'll probably do this using a some sort of JST cable that'll connect right into the solar. So I'm not going to put the LED in here. I'm going to put the LED off of the cable itself. And same thing, so this is going to be the left eye here, and the same thing happens when it blinks the right eye. It then feeds into here, which drives this pin. So it's going to go ahead and drive this pin over here when the right eye, and power in here to the anode of the LED, and the cathode is grounded. Now in the case that there is not enough power in the battery, it's then going to go ahead and drive this red LED, which is right over here.
And in this case, I have it on the base of what would be the transistor. I'm not using a transistor, I'm just using it as a pad for the LED. And that's going to turn on this red LED, which is an indicator. I believe it's set that, or the code was that it's 3.4 volts. It's going to turn on the red LED, and when it hits 3.3 volts, it's just going to continue the sleep cycle. It's going to switch off all the LEDs and just stay in sleep so that it can be recharged. And the charging module is right here. So the battery connects to it here. It then flows into a capacitor. Just to smooth it out, and right into the VCC then of the Attiny. There should be a decoupling cap here. I don't have one. I'm not sure if I'm going to bother soldering one in or not. It's not really needed. It's working fine without it. But if I was doing anything where there's more components, so perhaps on the PIR module where it's powering the VCC of the PIR as well, yeah, then it's probably a good idea to put a decoupling cap here. So let me go ahead and finish soldering the PCB, and hopefully we'll have a good replacement for the existing prototype PCB board that I was using for that owl.
So I've completed soldering all the components into the PCB, the TP4056 with the battery, the 18650 battery here. The Attiny85 has been programmed, and I actually use the programmer pins out here, the pin header here, to do that. The resistor is going into the pins with the PWM and then going into the LEDs to independently control each of the eyes here is working. Capacitor here just to kind of smooth things out, and the LED to show about a low battery period from 3.4 volts until 3.3 volts. This light will light up. Overall, seems to be working. I don't see any problems with the PCB at all. So quite happy with how everything has worked out. You can see here that the charging is also working properly. So this is the TP4056 module, and red indicates that it's charging up the battery, and it'll turn blue once it completes the charging cycle. So overall, good results.